The hyperbola is of the form y equals a over x minus p plus q, where a determines the shape of the graph, q determines the vertical shift, and p determines the horizontal shift. Y equals a over x minus p plus q. Right, so for the shape of the hyperbola, if a is greater than 0, then the hyperbola lies in the first and the third quadrant. If a is less than 0, the hyperbola lies in the second and the fourth quadrant. So how does a affect shape? So if it's 1 over 2x, then it's in the first and the third quadrant. And if it's 1 over x, it starts to get wider away from the axes. Y equals 2 over x, even further away. And y equals 4 over x, even further away. Now the hyperbola has an axis of symmetry, 2 of them in fact. So firstly, the hyperbola is symmetrical around the axis y equals x minus p plus q, and y equals minus x plus p plus q. 2 linear lines perpendicular to each other. What is the range and the domain of the hyperbola? Well, firstly, x, the domain is an element of the real number set. That means that x is an element of minus infinity to plus infinity, except that x is not equal to p. And the range, y is an element of the real numbers, or y is going from as an element of minus infinity to plus infinity, but y is not equal to q. Right, so take the example y equals 1 over x minus 2 plus 3. So the axis of symmetry then is going to be y equals x minus p or 2 plus q or 3. The other one will be y equals minus x plus 2 plus 3. If you have a hyperbola with a greater than 0 and you want to check where that intersects with the axis of symmetry, you basically take the equations for the hyperbola and the equation intersecting line of symmetry, and you make them equal to each other and you solve for x. And you do that fairly complicated calculation, and in a general sense you'll come out with this. Similarly, if a is less than 0, you'll come out with these particular coordinates. This is easily explained by an example. Let's take the equation y equals 1 over x minus 2 plus 3. Now, where does this hyperbola intersect with the axis of symmetry? Well, that can be done by putting the hyperbola equal to the axis of symmetry, and this is when x minus p plus q, the axis of symmetry, is equal to a over x minus p plus q, the hyperbola, or substituting into our particular equation when x minus 2 plus 3 equals 1 over x minus 2 plus 3. Right, so let's solve for x. So we multiply both sides of the equation by x minus 2. We gather up the terms, move them all to the left-hand side, factorize. You'll get x equals 1 or x equals 3. Substitute back into the line of symmetry and you get y equals 2 and y equals 4.